In this video, we're going to be finding arc length. Now, what we mean by arc length is the distance along a circle from a point to another point on the circle. So here, like S would be the distance from here around to here would be the arc length of S. Now, we used to do this a much tougher way. Let me remind you of that. If we knew that our angle theta here was, let's say, a 120 degree angle, then what we could do is we could find the entire circumference. If you don't remember how to find circumference, it's pi times diameter. We can find the whole distance around and then say, okay, we only want the distance from here around to here. So we only want this fraction, 1/20th out of 360, or 123/60ths of the whole circle. And we can multiply that together. Well, now there's a much easier way now. And we do have a formula for it. To find the arc length, and we call arc length S, is the abbreviation. S is equal to R times theta. If theta is the central angle, and we can see here that's the angle of, I guess you could say, the angle that's eating the arc. If theta is the central angle with the radius R, then the length of the intercepted arc S is given by S equals R theta, where theta, now this is the most important part, theta must be in radians. So that's a very good example of why do we even need radians? Well, this formula doesn't work unless your angle is in radians. Find the length of the intercepted arc given the angle, measure, and the radius. Give your answer in terms of pi. So we're not, and rounded to the nearest tenth. So we're going to give it in both forms. So if we have a central angle, that's our theta here. And so again, we have S is equal to, okay, that looks better. S is equal to R times theta. So our arc length is going to be the radius, which is 3, times the theta, which is 5 pi over 6. And it's as simple as that. We simply multiply it together. Cross cancel gives me a 1 and a 2. 5 pi over 2 is the length of that arc. Let me try to fix that, which is going to be about 7.9 if you type in 3.14 for pi. And I believe it does say round your answer to the nearest tenth, so you can use your pi button, should be able to, or type in 3.14 and that's what you get. And I believe that was in feet. So there's your two answers. So again, what you just found was 5 pi over 6. If you were to convert that, that's actually 150 degrees. So if you were to take this circle and you have a 150 degree arc, and the radius is 3 feet. The distance from here to here on that circle would be about 7.9 feet. Okay, number 2. Again, arc length is equal to radius times central angle. So therefore, arc length here would equal, our radius is 14.5. Our central angle is pi over 4. And they want us to leave it exact, so you can try to cancel this out, 14.5 and 4, or you can just go ahead and multiply it and do 14.5 pi over 4. We can then divide this to see what we get, and that's going to be equal to 3.625 pi if you divide that out. Or here's another option. If you want to get rid of that decimal, multiplying by 2 on top, if you double that, notice you're going to get a full 29. So if you multiply top and bottom by 2, you could also leave that as 29 over 8 pi. So either one of those would be fine. And then once you actually multiply that out, you're going to get 11.4, and that was in inches. So therefore, there's your actual decimal arc length when you plug in 3.14. Next one, arc length is equal to the radius, which is 0.5, times the central angle, which is 3 pi over 2. When you multiply that out, that gives you 4.5 pi over 2. And again, you could take the same two options. You could divide that. That would be 2.25 pi. Or you could double the top, and that would be a 9 pi. Double the bottom, that'd be a 4. So either one of those are fine for the for the pi answer. When you plug in 3.14 for pi, you're going to get 2.4. And again, this is in yards. That's the length along the arc. Number 4, 2 pi. Now, if you'll notice, that's actually the entire circle. 2 pi, what we're actually finding here is circumference. So let's see how we're going to do that. Arc length is equal to the radius, r times theta, which is 2 pi. Now think about how you find circumference. Circumference is equal to pi times diameter, but there's also an alternate formula, which is 2 times pi times radius, which is actually what we're doing here, 2 times pi times radius, because 2 pi is the entire arc length. When you multiply that out, you'll get 12.4 pi, which is the same thing as the diameter. If you double that, 12.4 is the diameter, so 12.4 would be pi times diameter. That's going to be your pi answer, which is going to be approximately 39.0 yards. Number 5. Now notice here that we're in degree measures, and S equals R times theta. The most important thing to remember is that theta has to be in radians, so we're going to have to come over here to the side. 15 degrees, we're going to have to change that to radian measures, so we're going to multiply by pi radians over 180 degrees so that our degrees can cancel. We can reduce that. 15 into 180 goes 12 times. So this is going to be pi over 12 radians. So your arc length will equal the radius times pi over 12 radians. That's going to be 8.4 pi over 12. So you can multiply top and bottom by maybe 10 if you just want to clean it up. That would have been 84 pi over 120 would get rid of that decimal. Then you can reduce to divide top and bottom by 12 would be 7 pi over 10. That's one way of writing your answer is there. And when you divide that out, you're going to get 2.2, and this was in meters. Number 6, 330 degrees. First off, we are going to have to convert that 330 degrees to a radian measure. So we're going to multiply by pi over 180 to get the degrees to cancel. Let's reduce that by dividing by, let's see, we could divide by 10 first, I should have, and that would get rid of my zeros. There we go. And then we can divide 33 and 18 by 3. That gives you an 11 and a 6. So that's going to be 11 pi over 6. So your arc length is equal to radius times angle. The radius is 10.5. The angle is 11 pi over 6. When you multiply that together, you get 115.5 pi over 6. You can double it if you want to get rid of the decimal, double top and bottom. That gives you 231 pi over 12. So that looks better. And that's actually reducible. You could divide top and bottom by 3, and that gives you 77 pi over 4. So that's a cleaner exact answer. And then when you actually plug in 3.14 for pi, you're going to get right at 60.5, and this was in millimeters. Number 7. First step, 120. Now here's another way I work it. I know that 2 pi is 360. And I noticed something about 120, that's a third of it. So you could actually say, well then 120 would be, since 2 pi is 360, a third of that would be 2 pi divided by 3. So this is going to be 2 pi over 3 in radians. So S, arc length, is equal to the radius, which is 1.8, times the central angle, which is 2 pi over 3 here. When you multiply that out, that gives you 3.6 pi over 3. And again, you could actually divide that and get 1.2 pi. Or if you want to clean it up and leave it as a fraction, multiply top and bottom by 10. That'd be 36 pi over 30. And then reduce it gives you 12 pi. Well, I could actually divide that by 6. That'd give you 6 pi over 5. That's the exact answer. When you plug in 3.14 for pi, that's going to give you about 3.8 feet. Number 8, 135 degrees. Let's convert that to radians. 135 degrees over 1 times pi over 180. Let's mark out our degree symbols. We can divide top and bottom by 5. That gives me 27 and 36. I can reduce that by 9. That's a 3 and a 4. So I could have actually divided 45 into both of those. So I have 3 pi over 4. is my central angle. So arc length is equal to the radius times the central angle, which is 3 pi over 4. So that one cleans up nicely, gives me 75 pi over 4. That's the exact answer. Type in 3.14 for pi and you get 58.9, and that is in kilometers. Okay, number 9 says the central angle theta of a circle of radius 6 has an intercepted arc that is 10 meters. So we're doing this one backwards. It gives you the arc length, S here, and it gives you the radius. So what they're asking you to do is find the central angle. S is equal to R times theta. If the arc length is 10 and the radius is 6, and they ask you to find the theta, they ask you to find the angle. Let me draw that a little bit better. It's very easy. Just solve the equation. And you get theta is 10 over 6. Now that theta is going to be in radians. So you got to, let's see, find the measure of theta in radians and in degrees. So we've got it in radians here, 10 divided by 6. That angle is going to be about, and keep in mind, this formula deals with radians. So whether you're plugging an angle in, you got to plug in radians. When you solve this and you're solving it for it, it's going to solve it in radians. So this 10 over 6, when you divide it, you're going to get 5 over 3. So you could just reduce it. And again, that's in radians. Or you could actually divide it out. That's going to be, and that was equal there, not approximate. That's going to be 1.6 repeating radians. So either one of those answers are fine. But now I want to change that to degree measures. And if you don't remember, if you have something in radians, so 5 over 3 radians. Now I'm going to put that over 1 because we're changing it to degrees. So I know that pi radians is equal to 180 degrees. So to change from radians to degrees, you multiply by 180 over pi so that radians cancels. Multiply the 5/3 times 180, and you're going to get, let's see, 1/3 of 180 is 60, so times 5 would be 300 over pi. And again, now it's in degrees. So when you actually divide that 300 by pi, you're going to get 95.5 degrees. Number 10 says a merry-go-round rotates 2,808 degrees per ride. Now, obviously, 360 is one rotation. How far would a rider seated 8 feet, so that would be from the center, that'd be a radius. How far would they travel during the ride? So now this arc length formula works for arcs greater than a full rotation as well. So they're going to go around 2,808 degrees, which is going to be several rotations. Well, first off, we've got to change that 2,808 degrees. We got to change that into radians so that it'll fit into our formula of S equals R theta. So that's going to be, we know that pi radians is equal to 180 degrees. So we're going to multiply by pi over 180. You can reduce that. You can actually divide by 36, and that's going to give you a 78 and a 5. So 78 pi over 5. And if you didn't understand that you could use 36, you could have used 4, you could have used 9. You can use smaller numbers up to that point. So our radius was 8 feet. Our radian or angle measure is 78 pi over 5. When you multiply that together, and you don't have to leave this exact, you're going to get 392.1 feet. And like I said, we didn't have to leave it as a pi answer because it just simply said what's the distance. And if you leave it as pi, a lot of times that doesn't make as much sense as what that distance actually was. Number 11, Cincinnati, Ohio is directly north of Atlanta, Georgia. Cincinnati has a latitude of 39.1 degrees north. Atlanta has a latitude of 33.7 degrees north. If the Earth has a radius of 3,960 miles, how far apart is the two cities? So this is a pretty interesting question. So we have here a radius, and our degrees north of 39.1 and 33.7, we can actually subtract those two because the way the Earth works, that degrees north, we can use those two angle measures, subtract them, and we can find out what that central angle is. So subtract 39.1 from 33.7 from 39.1, and we get a central angle measure, or a theta, of 5.4 degrees. Now that does have to be converted to radian measures, so let's multiply by pi over 180 so that our degrees cancel. And that's going to give us, obviously, 5.4 pi over 180. Let me zoom in so I can see that a little bit better. If we want to clean that up a little bit better, we don't have to, but just for extra practice, we can multiply top and bottom by 10, and that gives me 54 pi over 1800. Then I'm going to reduce by dividing by 9. Maybe to start with, that'd be 6 pi over 200. Then we can, now what I'll divide by there? Yeah. And then we could reduce again by maybe 2, and that gives me 3 pi over 100. So there's my radian measure. So my arc length is equal to the radius, which was 3,960 miles, times your angle measure, which was 3 pi over 100 in radians. Multiply the two together, and again, you don't have to give exact here. You get 373.2 miles. Okay, next up, we're going to be finding the area of sectors, not the arc length, not the distance from here to here, but the area of this shaded region. Now, we know the area of a whole circle, you don't remember, is pi times radius squared. However, the area of a sector of a circle given with a radius of r, and again, a central angle of theta, is given by the following formula. Area equals 1/2 theta r squared. So instead of the pi, we have 1/2 theta. So where theta, again, is measured in radians. Very important that we have it in radians there. So let's try one. Find the area of each sector. Again, area is equal to 1/2 theta r squared. So the first thing, we've got to take this theta of 74 degrees, and we have to change it to a radian measure. So let's multiply it by pi over 180 so that, again, our degrees cancel, and that gives us, well, we can reduce this. Divide by 2, that's going to be a 37 and a 90, and I think that's as far as it'll reduce, 37 pi over 90. So therefore, our angle we now have, so we have 1/2 times 37 pi over 90 times the radius, which is 4, and let's go ahead and square it, gives you 16. We can cross cancel anywhere we want, so that gives you an 8. We could cancel our 90 and our 8, and that's going to give me a 45 and a 4. So on top, we have 37 pi times 4, which is 148 pi over, and then we have a 45 on bottom. Now that's going to be your exact answer. However, I didn't notice, but on these, they don't even ask for exact answers, so you could have just multiplied this whole thing out. You get 10.3, and since this is area, you're going to be measuring it in square centimeters. Number 13. Step number 1, let's convert our 205 degrees to a radian measure by multiplying by pi over 180. Degrees cancel. And you can leave this, honestly, you don't have to reduce it because you're about to just type it into your calculator anyway. That'd be 205 pi over 180. So area is equal to 1/2 times theta, which is 205 pi over 180. And again, I'm not reducing because I'm typing it into the calculator, so there's really no sense in it. Times 11.2 to the second power. So you can multiply all the tops together, all the bottoms together, and then divide, or you can just type this straight into your calculator, and you're going to get 224.4, and that would be, again, in square feet, since this is measured in feet. Number 14. Now we're dealing with radian measures, which is going to be even easier. So the area is equal to 1/2 times the angle, 2 pi over 3, times the radius squared, which would be 49. Again, you can cross cancel if you want to, but you don't have to. On top, you have 49 pi. On bottom, you have 3 times 1, which is 3. You can leave it like that as exact, but they're wanting an approximate area answer. And when you type that in, you're going to get 51.3 kilometers square kilometers. Number 15. Again, area is equal to 1/2 theta r squared. So that'd be 1/2 times your theta here is 19 pi over 12 times the radius squared will be 23.6 squared. And I'm not going to type that in because we can just type the whole thing in together. But that's going to give you an approximate value, once you do, of 1,385.2, and that is in square meters. Okay, number 16 says the area of the sector is of a circle with central angle 240 is 134. So we're working this problem backwards. So let's write down our formula. Area is equal to 1/2 theta r squared, and plug in what we know. We know that the area is 134, so plug that in for A. We have our 1/2. We have our central angle of 240, but again, 240 has to be converted to a radian measure. So that's in degrees, so we're going to multiply by pi over 180. So our degrees would cancel. We can reduce this by dividing by 60. That gives you a 4 and a 3. So my angle is 4 pi over 3. So let's plug that in. 4 pi over 3 times, and we're looking for the radius, so times radius squared. So here it is best to clean up. We can cross cancel here. That leaves you with a 2 and a 1. So we now have 134 is equal to be 2 pi over 3 r squared. Now, reminder, to get rid of a fraction, we're going to go to the other side and multiply by the reciprocal. So let me rewrite this. That'd be 134 equals, when you move the 2 pi over 3 over, you're going to take the other side and multiply by 3 over 2 pi to get rid of it. And you can cross cancel there if you'd want to, or you can just type that whole thing in. And when you type this whole thing in, 3 times 134 divided by 2 pi, you're going to get right at 64. I think it's actually like 63.9899, something like that, is equal to r squared. So now to get rid of a square, we simply square root, and we get plus and minus 8. However, since we're talking about the radius of a circle, we can throw away the minus. So the radius is 8. The windshield wiper arm to the left is 32 inches long. And you can see that. Here's our arm here is 32 inches long. If the wiper sweeps through an angle of 125 degrees, find the area swept out by the blade. Now, working this problem, what they've actually done, the 32 inches, they let 32 inches be the distance from here to here. That's 32 inches. So what we've got going on here is the actual blade itself only swipes this portion. It's not gonna actually swipe down here. We know that from driving a car that this portion right here does not get cleaned by your windshield wipers. So we want to know the area that gets cleaned. So what we're going to do is we're going to go ahead and find the whole area for the entire arm, which is 32 inches. So the area, we'll call it area 1, is going to be, again, 1/2 theta r squared, to where the angle that it sweeps is 125 degrees. So let's come over here to the side, and 125 degrees times pi over 180. Degrees cancel. Reduce that, that's going to be a 25, and this will be a 36 when you divide by 5. So you have 25 pi over 36 is going to be our angle. So we have area 1 is 1/2 times 25 pi over 36 times the radius there of the big circle, the area of the big circle, using the radius of the big circle, which is a 32. So times 32 squared. Multiply that out, and you get right at 1,117. Okay, the second area. Let's see how much of an area does not actually get cleaned down here. Now, if the whole arm is 32 inches, this portion of it is 21 inches, so therefore that leaves you with 11 inches down here that doesn't get swapped. So we're going to do 1/2 times theta times r squared again. So our theta is going to be the exact same thing. Both arms are swept the exact same degree measure or radian measure. However, the new radius here is 11, so times 11 squared. Multiply all that together, and you get 100, right at 132. And now this is in inches, so these are in square inches. So the entire area swept out by this windshield wiper right here, this sector is 1,117. However, the sector swiped out down here is 132 that does not get clean. So take those two values and subtract them, and you get a value of 985. And that's how many square inches gets cleaned by these windshield wipers.